starting off with the cervical from top to bottom. We start off with the two atypical. Yeah, starting off with the two atypical cervical vertebrae, which is C1 and C2. These vertebrae include the atlas and the axis. The atlas is the vertebra that holds up your head. Now, the name Atlas comes from the Greek myth that somebody named Atlas is holding up our globe, and that is where that comes from. Now, going back to anatomy and away from Greek mythology, the atlas has no body or spinous process. As you can clearly see here, it has no body and no spinous process. You can see that's obvious, right? What does it have instead? It has tubercles. It has an anterior tubercle instead of its body, and it has a posterior tubercle instead of its spine. Logical? Logical. Now, it also has two lateral masses. These are unique only to the atlas. The two masses, or the two lateral masses on each side, contain superior and inferior articular surfaces. Now, the superior articular surfaces, as you can see in the atlas, are incredibly large. What is the necessity? If you remember, when we went through the occipital bone, we said that the occipital bone has the occipital condyles, which the occipital condyles articulate with the superior articular surface of the atlas. Makes sense, correct? Now, it also has the transverse process, as you can see on either side, and the transverse foramen required for, which is present in all the cervical vertebrae and is required for the vertebral arteries. And it also has a articular surface for the dens of the axis, which we will get to in just a second. But I just want you guys to know what the atlas looks like and all of its small tiny details. Alright, moving on. This is another image of the axis, but with something that you might, sorry, of the atlas, I'm sorry, but with something that you might notice is not present here, which, my good friends, is the transverse ligament of the atlas. And just keep that in your mind just for a second until I explain the axis, and I will get back to this and its importance. Now, the axis is the second bone, or C2. The axis also does not have a body, but it does have a spinous process, as you can clearly see. Instead of a body, it has a dens. Fair enough? The dens is a superior projection. So this is again 2D. If you were to imagine it in 3D, the dens points upwards. It goes straight up. And we have the superior articular facet to hold the atlas, and the transverse process, as well as the transverse foramina, with the lamina and the spinous process, which are general for all vertebra, and we also have the vertebral canal for the spinal cord, logically, and the medulla. In the region of the atlas, the vertebral foramen is very large because it needs to accommodate for the size of the medulla oblongata and the brain stem, because we are just leaving the brain right now, so it's the brain stem region. Going down, it will narrow down to only accommodate for the spinal cord. Now, remember when I said, remember that we have this ligament, the transverse ligament of the atlas? The transverse ligament of the atlas, if you were to imagine putting this and this on top of each other, you would see that the transverse ligament of the atlas would come right across the dens, as you can see here. The dens, and this is the atlas, and this is C2. This is the axis. And as you can see here, the facets are articulating, and everything is perfect. Everything's amazing. The dens and the transverse ligaments of the atlas, the dens acts as a pivot for the atlas, so that when you nod your head no, if you were to go right now and nod your head no, you were to imagine the dens acting as a pivot and the atlas pivoting around the dens, with the transverse ligament of the atlas holding it down and holding it all together. Makes sense, correct? I will try to put like some sort of short video to guys get it from your GIF or something. You'll see it. Now, this table on this page right here is a table that would summarize pretty much every detail or every characteristic of all the vertebrae, including cervical, thoracic, lumbar. Now, I will go through them individually, of course, but if you want to read it, there are some extra stuff here that I might not mention. You can go ahead. So, the typical vertebra, C3 to C7, or the typical cervical vertebra, C3 to C7, have a wider body horizontally or laterally, because there's not much weight bearing on the cervical vertebra. The body itself is more rectangular in shape, and the lamina or the vertebral foramen is more triangular in shape, and it has the largest vertebral foramen throughout the whole spine, vertebral canal or whole spine, because it needs to require for the brainstem in the thickest regions of the spine pass through here. The spinous process in this case is bifid or bifurcated. As you can see, it splits into two regions right here. This is called a bifid or a bifurcated spinous process. The pedicles are thin and not that thick. We have also the transverse foramen present, which is a necessity for the intervertebral arteries, or sorry, for the vertebral arteries. Transverse foramen, which is a necessity for the vertebral arteries. And C3 to C6 are one hand, and C7 is considered or known as the landmark. If you were to touch the back of your neck right now, that hump that you might feel, some people have a much more prominent one. That hump is the landmark of C7. It is used for surface anatomy to know where C7 starts or where your cervical uh, vertebra end. The spinous process also project directly posterior, as you can see right here. They are direct posterior projection, and they are bifid, like we just said. One more thing that I want to mention about the cervical vertebra is a cute little animal that they look like. If you are to imagine the cervical vertebra, as you can see it right here, you can know it by the spinous process. It's bifid. You can sort of see that it looks like a baby elephant's head. If you want, it can help you remember or imagine or memorize the cervical vertebra. It looks like a baby elephant head. You can kind of see the transverse foramen, the spinous process, the whole regions. Now, moving on. The table again, it will be there before every type of vertebra. Moving on to the thoracic vertebra. Thoracic vertebra, which are the vertebra present in your chest. And one more thing that is present in your chest and goes around the whole circumference of your chest is your ribs. So logically, if your ribs are there and your spine is there and they both meet somewhere, there needs to be a point where they meet. And you are correct. They meet at the costal facets. Now there are two costal facets, superior costal facet and the transverse costal facet, as well as the inferior costal facet, but we'll get to that in a bit. Now, in general, the thoracic vertebra articulates with all 12 ribs. So all 12 vertebra, all 12 ribs, they meet up together. It has superior and inferior costal facets at the body region. So in the region of the body, again, draw a line. The body of the vertebra has superior costal facet and inferior costal facet. That is completely logical. We also have, because the ribs are very long in size, they're very long in shape, they are very long bones, they need to articulate at two separate regions. So imagine it with me. They need to articulate here at the superior costal facet, and they also need to articulate at the transverse costal facet, and then go around, because they're very large bones. So if you think about it in a physics point of view, it makes a lot of sense for them to have two regions of articulation with the ribs. Now, as you can see here, the body of the thorax is more heart-shaped. The body is a bit more heart-shaped, and the vertebral foramen is more constricted or smaller than the cervical vertebra. The spinous process, on the other hand, is very straight and long, and is pointed directly inferiorly. So it points right down. The spinous process points right down, and the transverse processes have facets, like we said, that articulate with the ribs, not to mention the facets that already come with it, the superior and inferior articular facets that are already present on all vertebra. However, T10 and T12 only have single facets. Keep that in mind. So all of them have double facets except T10 to T12 have single facets, because the ribs become smaller at that region. You will understand when we show you the rib cage and go through the bones of the rib cage or the ribs. Another animal that the spine or the vertebra looks like here is the giraffe. As you can see here, it is a perfect match. The thoracic vertebra looks exactly like the head of a giraffe. Again, it might help you guys remember. Thought it would be fun to put in there. The table again, going into the lumbar. Now, the lumbar vertebra are the most weight-bearing vertebra. They are the heaviest, thickest, toughest vertebra out there. Why? Because they need to be able to carry your weight down to the sacrum so that the sacrum can then diffuse it to the pelvis. Now, the body of the vertebra here, the body of the lumbar vertebra, is a very thick bone. It is the thickest of all of the vertebra, and it is larger vertically than horizontally. It is very sturdy, and considering that all of the weight is on it, it has a very short pedicles and short lamina, unlike the rest of the vertebra. There has the transverse processes and the supraortical processes, and the only distinctive feature here is the spine. It is hatchet shaped. I'll put an image of a hatchet here. It is hatchet shaped spine, and it is flattened out and posterior, direct or straight posteriorly, like the cervical vertebra, except here it is not bifid, it is hatchet shaped. The foramen, the vertebral foramen here is triangular in shape, because at this point there's the spinal cord is at its thinnest region, and then it will end in cauda equina, or the end of the spinal cord. Now, the animal that the lumbar vertebra look like is a deer. Again, you can see like the antlers, sort of, it's very nice to look at. Now, moving on to the last two regions, which is the sacrum and the coccyx. Again, cannot get over that name. The sacrum is formed of five fused vertebra. As you can see here, well, you can't really see, but you can sort of see remnants of the vertebral spinous processes. Anyway, it is formed of five fused vertebra. Take my word for it. And it is the bone that binds or connects, let's say, to the pelvis. As you can see here, this is the sacrum. It connects to L5 here, and this is your pelvic girdle. And this little one is the coccyx. Now, this is known as the apex of the sacrum, and this is the base of your sacrum. And if you were to look here, look at these specific landmarks that you can clearly see, we have something known as the median sacral crest. The median sacral crest is the remnants of the spinous processes of the five fused vertebra. Right here you can see this is the median sacral crest. And right down here we have something known as the sacral hiatus. The sacral hiatus, this region, is because that the S5 does not have a spinous process. So S1, 2, 3, 4, no S5, because this S5 does not have a spinous process. Now, another thing that you might be able to see is the posterior sacral foramen, which is very, very, very important. I cannot stress on how important it is for the sacral nerves to pass through logically, right? It's very logical, it's very easy. Now, one more thing that I want to mention from the S1 is that there is a remnant, or a let's say projection from the anterior edge of the S1, which is known as the sacral promontory, which is important for ligament and muscle attachment. We also have the superior articular processes, where it binds to L5. We have the S1, S2, S3, S4, and S5 right here, and all of these little lines are the transverse lines. Again, they are remnants, or the regions of fusion between all of the sacral vertebra. We have on either side, or laterally from the S1, we have the sacral ala, also known as wings of the sacrum. They project on either side, and that is their name, sacral ala. We have the sacral tuberosity. This is on the posterior view of the spine, or of the sacrum, sorry. On the posterior view of the sacrum, we have the sacral tuberosity, which is a site for ligament attachment. And before we mention the sacral hiatus is a continuation, or if you look from here, you will see the sacral canal. The sacral canal is, again, the region where the spinal cord passes, or the end of the spinal cord passes. The sacral cornu, also known as the sacral horns, are these two little indentations here. These are known as the sacral cornu, and they are landmarks that some people, you can actually sense in some people, to tell you where the end, or the S5, is present. Now, we also have one last thing to mention. We talked about the median sacral crest. The intermediate sacral crest is the region of the, or the remnants of the fusion of the articular process, sorry, and the lateral crest is the regions of, or the remnant of the transverse process of the vertebra of the sacral vertebra. So, one last time. Median sacral crest is the spinous process, intermediate sacral crest is the articular process, and the lateral sacral crest is the transverse process of the vertebra. Ala, on the sacral ala, we have the auricular surface, which is the regions for the articulation with the pelvis. Now, going on to the coccyx, again, that name, it sort of looks like a worm. If you were to see, it has a base right here, it has an apex right here. It is formed of four fused vertebra. There is really not much to talk about. It's just the tailbone that is present there, C1, C2, C3, and C4, and they're all fused together, with the transverse process of C1 being most prominent. The rest are all fused and broken down, sort of. So that is pretty much it for the vertebra, for the spine. I'm pretty sure this video is going to be a bit too long, so I will cut it off into two parts so that you guys can better grasp the idea and not be too overwhelming for you guys to learn and understand. I hope you guys enjoyed. Thank you for watching, and I'll see you guys in the next one.